like me as...
Sir, I could barely see the board.
You cannot see the board?
Yeah.
Share the screen. Stop share. Why? I am sharing the screen.
Like the one you were writing on.
Let me see if I can share it with you. Screen share. And then, can you see now screen?
Yes, yeah.
You didn't see that thing before?
No, I couldn't see it before.
Okay. So let me explain these things again then. So now today we are going to learn counting principle, and the first counting principle is known as the basic principles of counting. Basic principles of counting, okay? So in these basic principles of counting, suppose I want to buy a car. So then the car has many different characteristics. It has a brand. So it could be Toyota, Honda, GM, BMW, Kia, or Jeep, or Mini. And then there is a color: black, white, red, gray, silver, and engine types. So it's 8V engine, 12V, 6V, 4V, origin, whether the car is produced in USA or Europe or Canada, something like that. And then there is a types of car or vehicle which are known as the compact, sedan, SUV, truck, van. So from this, we want to find how many ways a person can buy a car. Okay. So from there, we want to know how many ways a person can buy a car. A person can buy a car like this way. A person can buy a car like that way. A person can buy a car like this way. A person can buy a car like this way. He can buy a car like that way. He can buy a car like that way. He can buy a car like this. He can buy a car like that. So a person can buy a car like this way. He can buy a car like this way. He can buy a car like this way. Okay. So how many ways a person can buy a car? That is the 7 times 5 times 5 times 5 times 5. So now suppose a poor boy like me has 3 shirts, 2 pants, and a pair of shoes. That means 1 shoe. Okay, a pair of shoes. So how many ways he can dress? How many ways he can dress for his graduation party? Graduation party. So previous example was a very big example, right? How many ways? The total multiplication is how much? 4,375. So that is a very big example. So visualizing is very tough. But now take a look at that charts. Charts 1, 2, 3. Pants 1, 2, 2, 1, right? Now take a look at that. This is one way, that is one way, right? So that is equal to 2. So now take a look another color. Another color. This is one way. That is another way. That is equal to 2. Right? Take another color. Another color in here. This is another way. And this is another way. So that is equal to 2. So altogether 6. So 3 times 2 times 1 equal to 6. Understand? So this is a small scale example. That one is a big scale example. Any probability book, when you start reading probability, the first chapter, first topic they discuss is known as the BPC, Basic Principles of Counting. Are you okay? You understand, right? Any question come to the exam that related to the basic principles of counting, you can immediately answer, right? So I finished one counting principle. Grace, you can see, right, Grace? Grace Osibanjo, can you see?
Yes, yes, I can.
Okay, so I finished first one, BPC, known as the basic principles of counting. Now I want to do permutation. Permutation thing I want to do. So what is permutation? Ordering matters. That means order matters. Order matters. Okay? Order matters or ordering matters. What does this mean? This means suppose we have a letter. Okay? We have a letters. What are the letters? A, B, C. A, B, C. 3 letter, right? 3 letter. So 3 letter, I want to arrange them. I want to arrange them. Arrange them. How? So I can write ABC. I can write ACB. I can write BAC. I can write BCA. I can write CAB. And I can write CBA. Okay? Are you understanding? 3 letters ordering matters. These 3 6 ordering matters. ABC, ACB, BAC, BCA, CAB, CBA, right? Otherwise, they are fighting. Unless 3 of them decided, well, make a random choice. So this is order matters. Okay. But how can I find these? By using mathematical formula. BPC we computed by using mathematical formula, right? BPC? By using mathematical formula. What is the mathematical formula? Multiplication, right? BPC is just the multiplication, right? Thank you. Now, what is the formula for this one? This one formula is this. 3 permute 3. Okay? This is the formula 3P3. P stands for permutations. 3 permute 3. What is the formula? Factorial 3, 3 minus 3. Okay? So 3 minus 3 equal to what? Factorial 0 and factorial 3. What is the definition of factorial? The factorial definition is this. Yes. Yeah. So factorial n equal to n times n minus 1 and n minus 2 times n minus 3 up until 3, 2, 1. So factorial 7 equal to, factorial 7 could be written as 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. This is the definition of factorial. So now factorial 0 equal to 1. I am going to discuss it. Why factorial 0 equal to 1? Factorial 1 equal to 1. Okay. Factorial 1 equal to 1. Factorial 2 equal to 2 times 1 equal to 2. Factorial 3 equal to 3 times 2 times 1 equal to 6. Factorial 4 equal to 4 times 3 times 2 times 1 equal to 24. Okay. So factorial 0 equal to 1, factorial 1 equal to 1. I'm going to discuss this later, but for now, just try to understand how the factorial works. So factorial 0 equal to 1, factorial 3 equal to 6. So we have 6, right? Are you understanding? This is by visual constructions. This is by construction. This is by mathematical formula. Are you understanding? Are you understanding? What did I say? Permutation, right? Permutation means what? Orders matters. Order matters. Otherwise, you will start fighting yourself. Okay? When orders matters, then this is called the permutation. Okay. Now, there are 3 letters. I have arranged all of the 3. So let me write it. There are 3 letters and I arranged them all. There are 3 letters and I arranged them all. Okay. So there are 6 ways 3 letters can be arranged among themselves. You don't agree, right? So this is what we have shown you by construction and by mathematical formula. Now I want to show you another thing. We want to select 2 letters. We want to arrange 2 letters from A, B, and C. We want to arrange 2 letters. How many ways 2 letters can be arranged? A, B, A, C, and then B, A, B, C, then C, A, then C, B. Right? Can you get any other arrangement? No, right? No, right? So 3 permute 2. Okay? 3 permute 2. Take a look at the 3 permute 2. Factorial 3, 3 minus 2. So what are you getting? Factorial 1, factorial 3. So factorial 3 equal to 6 and 1 equal to 6. This is by computation. This is by construction, right? Are you understanding? How do you know a problem is a permutation problem? By reading the question, you have to understand. Next problem, next computational method, next counting method is known as the combination, where orders does not matter. Clear? Are you understanding? First, I started basic principles of computing. Then I started permutations. Now I am going to combinations. Clear? Are you understanding? Okay. You see, I send you the YouTube link, right? I am uploading all the materials in there. In that way, what will happen? You don't need to log into computer and want to watch all of this, okay? I never created YouTube channel before, but I have seen some of my colleagues, they are doing these things. In that way, if you just search by name, then you will immediately get it. Okay. You understand to a small scale problem of permutations. Now, same problem we want to do by using combination. Combination, which is order or ordering does not matter. Clear, right? Ordering does not matter. So we have three letters A, B, C. As ordering does not matter, so what is the formula? 3 combination of 3. 3 combination of 3. 3 combination of 3 could be written as factorial 3, 3 minus 3. Okay? So now, is this cancel? Factorial 3 minus 0 equal to factorial 1, 1 equal to 1. Factorial 0 equal to 1. So that means this is the only way you can compute this. Are you understanding? The girl in the back, are you okay? Are you understanding? Sure? Good. Very good. Now let me convince you, ordering does not matter. 3 letters, A, B, A, C, and B, C. All is distinct, right? A, B, A, C, B, C, ordering does not matter, right? Now let's take a look at the formula. 3 combination of 2, 3 combination of 2, factorial 3, factorial 2, 3 minus 2, factorial. So we got here 6, we got here 2, we got here 1, so 3. This is by computations, this is by construction. Are you understanding? Yes. Let's see. Yeah, right? What?
You can bring up the screen of the
Yes. Okay. So from there, you understand what is BTC. Number 2, permutation. Number 3, combination. Okay. Now, I want to give you a small scale problem so that you can see it psychologically. You can put it in your head whether this computation is true or not. Okay? Problem. How many ways the letters of the word egg can be arranged? Okay. Number 1 question. Number 2 question. How many distinct ways? How many distinct ways the letters of the word A, B, arranged? How many ways the letters of the word egg be arranged? How many distinct ways the letters of the word egg be arranged? What is the difference? There are 2G, right? There are 2G, right? Take a look at that. Distinct ways. Distinct ways. No distinction. I can write here E, G1, G2. Because there are 2G, E, G2, G1, because there are 2G, right? And then G1, E, G2, G1, G2, E, G2, E, G1, G2, G1, E, right? You agree or not, this one? You agree this one or not? Yeah, what is the question? I thought that exactly, this is both G, right? So I said the first question, how many ways the letters of the word A can be arranged? So this is the how many ways, right? How do you know both of these are separate? That is what I'm going to separate now. Okay? Here I put a level 1 and 2 so that you can distinguish. You understand, gentlemen? I put the level so that we can distinguish, right? Are you understanding? This is the question 1. How many ways the letters of the word egg be arranged? And that is the question number 2, where E, G, G distinct, G, E, G, and G, G, E, right? 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 Distinct way. So now the question is, it is a small scale problem with just 3 letters. I can do it by construction. How can I do it when there is a word that has more letters, 5, 6 letters? Do you understand the question? Now this is a 3-letter problem. I can construct easily by paper and pencil, right? Are you understanding? This is a 3-letter word, A, and I ask you to construct how many ways the letter of the word eggs be arranged. Second question I am asking, how many distinct ways the letters of the word egg be arranged? That is the question. As it is a 3-letter word, without considering any mathematics, I just take the paper and pencil and write it. I got this result, right? And it took me just altogether less than 1 minute, right? Now, yeah, I can say that right, this is the distinct ways. So if this G comes here, that G comes here, there is no way I can distinguish unless I put a label there 1 and 2. Are you understanding? Unless we put a label there, we cannot distinguish them, right? Are you understanding? Are you understanding? There is a rationale why I said that. There is a rationale why I said. How many ways and how many distinct ways the words of the letter tenacity, right? Are you understanding now? How many ways the letter of the word Tennessee be arranged? Is there 1 E or 2 E? 1 E, right? So there is a 1 E. Right? This is the word. This girl. You understand why I asked this question? Because egg is a 3-letter word with 2 repeating letter G. If I ask you any question in the exam that has a 2 repeating letter with the total number of letter is 3. You don't need any mathematics. You just take the paper and pencil and start listing and give the answer, right? You understand? How can you solve the problem? Here is the what else. You have to bring your grandparents from the graveyard in order to list all of these. Are you understanding? How many ways the letters of the word Tennessee be arranged? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 permute. 9 permute 9, which is equal to factorial 9. Factorial 9 equal to what? Can one of you help me, please? Or maybe I can go there.
It's
Yeah.
362,800.
Okay. Okay. You understand? So 362,880. 362,880. That many times you have to write the letter of the word Tennessee. You understand why I said you have to bring your grandparents, all of them have to be locked in a room to write all of this? You understand? Fortunately, our forefather gave a formula to compute all of this. Are you feeling interest to learn these things? Are you okay? What do you think? I give you a small scale problem 8 with 2 repeating letters, which you can easily find just by listing. But now, what will be the formula so that you can find how many ways the letter of the word Tennessee be arranged, how many distinct ways the letter of the word Tennessee be arranged? Do you understand 2 questions? So one question is, how many ways the letters of the word Tennessee be arranged? Be arranged. Number 2, how many distinct ways? The letters of the word Tennessee be clear, right? I have to convince you by visually as well as psychology by giving a small scale example, and that if that small scale example is true, then we can apply same rule for the large scale problem, right? Clear, right? Now take a look. Take a look now. Can any one of you tell me one word with 4 letters, 3 of them are same. I want to see your English knowledge. I want a English word. I want a 4-letter English word. 3 of those letters are the same. Do you understand? Give me a name of English word that has a 3 repeating letters. It's good. Give me English word that has a 3 repeating. Do you understand what I said? Egg has 2 repeating letters, right? Give me English word that has a 3 repeating letter. Who is very good in English? How was your high school English score? How was you? This girl. You don't know? This boy. A English word that has a 3 repeating letter. A English word with 4 letters, 3 of them are the same. At least one time in your life you already use these things. One English word with 4 letters, 3 of them are the same. No idea. What?
Lull. L-U-L-L. Lull.
L-U-L-L. Okay. But that things, did you use in your life? There is another word that sometimes you use.
You're the lull in the conversation.
L-U-L-L, right? Right? So what is the meaning of this?
Yeah. Yeah.
What?
Lull.
Pause. So this has a P-A-U-S-E pause, right? How about this one? Sassy, sass. You use a lot this one. You use sassy. All of us use sometimes in your life. At least one time we use sass, right? Okay. I want to convince you by giving this small scale problem so that it will be well said in your head that the formula is correct. You understand? I give you a English word with 2 repeating letters, and how many distinct way eggs you have done? Eggs has egg. Okay. So how many ways? 3 permute 3, which is equal to 6. How many distinct way? 3 permute 3 divided by 2 permute 2. Why 2 permute 2? There are 2G. So this is the distinct ways. So 2G said, so that is a 2 permute 2. So that means there is a 6, there is a 2, there is a 3. So that 3 equal to this. EGG, GEG, GGE. That is the mathematical formula. That is the mathematical formula. How many distinct ways? Understand? How many distinct ways? That is the mathematical formula. 3 permute 3, that means 3 letters can be arranged among themselves by 3 permute 3. How many distinct ways? 3 permute 3 divided by 2 permute 2. Clear, right? Clear, right? Okay. I'm going to write the final formula, very beautiful format, but let me solve the SAS problem first. Okay. So the letter SAS so the word SAS has 4 letters. 4 letters with 3 repeating letters. 3 repeating letters S. Okay. So number 1, how many ways the letters of the word SAS be arranged? 4 permute 4, right? 4 permute 4, which is equal to 24. Clear, right? So let me write this 24. S1, A, S2, S3. S1, A, S3, S2. S1, S2, A, S3. S1, S2, S3A. And then S1, S3, A, S2. S1, S3, S2, A. Are you agreeing with that? S1 is standing in the front. Okay? And then if S1 is standing in the front, S is standing in the front, this S, these three letters can be arranged among themselves 6 ways. 1, 2, 3, 4, 5, 6. Understand? Three letters can be arranged among themselves in 6 ways, right? S1 gone. Now, S1 in the front, I want to put now A. I want to put now A. I want to put now A, S1, S2, S3. A, S1, S3, S2. A, S2, S1, S3. A, S2, S3, S1. A, S3, S1, S2. A, S3, S2, S1. Do you agree or not? Clear, right? Now S1 A is gone. Now S2 A, S1, S3. S2 A, S3, S1. S2 S1 A, S3. S2 S1 S3 A. S2 S2 S3 S1 A. S2 S3 A S1. Okay. Now finally S3 A S1 S2. S3 A S2 S1. S3 S1 A S2. S3 S1 S2 A. S3 S2 A S1. S3 S2 S1 A. Clear, right? Okay. So question number 1. How many ways? How many ways? How many ways? Question number 2. How many distinct ways? How many distinct ways? Distinct ways. So how many ways? That is what we already did. 4 permute 4, which is equal to 24. So this is what this 24. Clear, right? These 24 ways. Now, how many distinct ways? I have to do the visual inspection. 4 permute 4 equal to 24. 4 permute 4 equal to 24. Are you understanding? If you do not understand, please let me know. Now, take a look. If I take out this, so our first problem, first one is how many ways? How many ways the letters of the word says be arranged? The answer is 4 permute 4, which could be written as factorial 4, 4 minus 4 by the formula. Factorial 4 over factorial 0 equal to 24, which is that. Now I want to do the second one. How many distinct ways? How many distinct ways? Distinct ways the letters of the word says be arranged. Answer is what? Only one way? Four way? Okay, let me check. That could be done by 4 permute 4. And then how many repeating letters? 3. 3 permute 3. Okay? So 4 permute 4 equal to 24. 3 permute 3 equal to 6. Now there is a 4. Okay? We have to find this 4. Okay? We have to find this 4 from this visual inspection. Take a look at when A is the second place, I am erasing everyone by keeping this one. A is in the second place. A is in the second place in here, here. A is in the second place here and here. A is in the second place. This 4 has been cancelled. A is in the second place. Okay. A is in the second place in here. It has been cancelled. Out of 6, 5 of them is cancelled. S1 is the first place. Everything else would be cancelled. So this is S1 is the first place. This and that. So I want to keep this one. And let's see. And that one should be cancelled. That one should be cancelled. This one should be cancelled. 3 cancellation. This one should be cancelled. And this one should be cancelled. Okay. In this case, A is in the third position. A is in the third positions. I keep only 1. I cancel the remaining 5. Because if I take out the level, these are the same, right? Okay. Now, A is in the last position. A is in the last position. I want to keep this one. I want to cancel that one. A is in the last position. A is in the last position. A is in the last position. This has been cancelled. Okay. A is in the first positions. This should be kept. This is cancelled. 5 cancelled. So we have already 4 scenarios, right? Understand? So now, if I ask you in your exam, how many ways and how many distinct ways the letter of the word mathematics, statistics, Mississippi, right? How many ways the letters of the word mathematics, statistics, Mississippi, and how many distinct ways the letter of the word mathematics, statistics, and Mississippi be arranged? What would be the answer? So it would be the answer for the Mississippi one, number 1 and number 2. Number 1 is how many ways? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 permute 11. That is the answer, okay? And then how many distinct ways? 11 permute 11. So how many S? There are 4 S, right? So that means 4 permute 4. And how many I? 1, 2, 3, 4. So 4 permute 4. Understand? That is the multiplication. And then how many P? 2. So 2 permute 2. Clear? Are you getting it or not? Clear, right? Now, what is the general rule or permutation and combinations? So this is the permutation general rule. Permutation and dx. So formula is factorial and factorial n minus x. This is the general rule of permutations. This is the general rule of combination. And cx, which is written factorial n, factorial x, and minus x. What is PPC? PPC equal to just multiplication, right? Category N1 times N2 times Nk. If there are k categories, this is the way. So what we have learned? We have learned what is PPC, what is permutation, what is combination. Okay? These are the general rule. NPX, NCX, N1 times N2 times N2. Any question? So you are understanding, right? So in the exam, if I give you a problem, how many ways the letters of the word Tennessee, Mississippi, mathematics and statistics be added? How many distinct ways? So distinct ways means there are a repeating letter, but if you put a label corresponding to each letter, then it will be distinguishable. If you do not put any label corresponding to each letter, each repeating letter, then it is not distinguishable, right? Okay. Y factorial 0 equal to 1, factorial 1 equal to 1, factorial 2 equal to 2 times 1 equal to 2, factorial 3 equal to 3 times 2 times 1 equal to 6, factorial 4 equal to 4 times 3 times 2 times 1 equal to 4, factorial 5 equal to 5, 4. Y real 0 equal to 1 and factorial 1 equal to 1. Why should I believe that? Why should I believe that? I will give you a second. I give a little pause, right? Purposefully. I want you to think a little bit about this. Why factorial 0 equal to 1, factorial 1 equal to 1? If factorial 0 equal to 1 is not assumed, and if there is not a worldwide agreement on the factorial 0 equal to 1, then this computation formula will not work. Permutation and combination will not work when you choose all from all. Do you understand what is all from all? 3 letters from 3 letters. 3 choose 3. You understand? So factorial 0 will appear in 2 scenarios. Remember these things. Factorial 0 will appear only in 2 scenario. 2 scenario factorial. What is the scenario? Number 1, choosing all. If you choose all, choosing nothing. How? For example, 3 letter A, B, C. You choose 3 permute 3. 3 permute 3. Or you choose 3 combinations 3. You understand, right? Choosing all. In that case, factorial 0 appear. Or choosing nothing. 3 permute 0 or 3 combination 0. Only in these 2 scenarios, factorial 0 will appear. Are you understanding? Factorial 0 will appear in the computation or calculation only in the 2 scenarios, when you choose all from all or when you choose nothing from all. In such a case, in order for the permutation and combination formula to work, we have to assume factorial 0 equal to 1. Otherwise, the results that we get from the calculation will not be true. For example, 3 permute 3, we got factorial 3, and 3 minus 3 equal to factorial 0 and factorial 3, which is give us 6. If we do not assume these things, then this 6 will not come. And this 6 is true that I have shown you ABC, ACB, BAC, BCA, CAB, CBA. I have shown you these things. Okay? Now, these things will also appear 0. If you take the 0, 3 minus 0, in that case, factorial 3 over factorial 3, which is equal to 1. Now take a look at that. I'm going to give you an example. Suppose we have 3 pen. One is green. We have 3. Suppose we have 3 pens. 3 pens. Take a look. The logical explanation. Suppose we have 3 pens. What are the pens? This is a black pen. This is a green pen. This is a orange pen. Understand? 3 pen. We have a 3 pens. Okay? 3 choose 0. 3 choose 0 means what? 1, right? If I do not move this pen, if I do not shift this pen, if we do not do anything with this pen can stand forever in this format, where black is always in the front, green in the middle, orange in the last. So this is the only one format these 3 pen can stand, right? Only one format these 3 pens can stand. if we do not move them, if we do not shift them, if we do not arrange them, if we do not touch them, so that means 3 permute 0. 3 permute 0 means only one. This is the only one way 3 pan can stand, where black will be in the first position forever, green will be in the second position, and then orange will be in the third position. You understand the explanation? So if you do not choose anything, that means there is only one way. So the way it is standing there. So that's the rationale why factorial 0 equal to 1. Okay. Now take a look. Factorial 0 equal to 1. If I do these things in this format, if I do these things in this format, 3 combination of 0. So that means what we are getting, factorial 3 and factorial 0 and factorial 3 minus 0. That is equal to also 1. And this is the only one. Clear, right? So remember this example, if your younger brothers or sister are down the road, someone will ask you why factorial 0 equal to 1, you will give them. Suppose there are 4 pan or 3 pan standing in this format, and I do not want to remove them, I don't want to change them, I don't want to touch them, I don't want to shift them, and then there is just the 0, I will never touch it. So that means 4 choose 0. 4 choose 0 means only one way you can choose 4 choose 0. So that is what it is standing. It will stand in that format forever. Yeah, right? Okay. So now after this, I have given you explanation why factorial 0 equal to 0. I have given you explanation why factorial 0 equal to 1. So far, if you are not in the class, watch the lecture, then you will understand. I gave the explanation, okay? So far BPC, permutation, combination, and meaning of the factorial, I have discussed. Okay. Now let us solve a problem. Our volume has 6 letters. Our volume has 6 letters. Arrange the letters also for volume so that L always stand at the first position. L always stands at the first position. Can anyone of you do this? Now, 1, 2, 3, 4, 5, 6, right? Right. And first position, L, right? How many letters remaining? So then, 5. I want you to tell me in terms of formula. L is always in the first position.
Second box is 5, third box is 4, fourth is 3, 2, 1.
Yeah. You understand this or not? Yeah. You understand this? So that means here is 5 letters, right? 5 permute 5, right? 5 permute 5 means factorial 5. 5 minus 5, which is equal to factorial 5 and factorial 0, which is equal to factorial 5. 120, right? More explicitly, if you want to ask me, could you give me more explanations? Well, so more explanation is, as first position is gone by the L, second position by one of the 5 letter. This position should have either B or O or U or M or E, right? This position. So if you want to do it in terms of the basic principles of counting, this is L, 2, 3, 4, and 5. This position should be B, M, O, U, and E, right? So now, one of these, let me cancel this. One of these gone in here. So next position would be by 4. Suppose B is gone there, then there should be M, O, U, E. And then, if you do these things, suppose M is gone there, O, U, E. And then there is a O is gone there, there is U and E. And there is a 1, U is gone there, E. So you remember the basic principles of counting. 1 times 5 times 4 times 3 times 2 times 1. BPC, basic principles of counting. You understand this one, right? How many, the letter volume has, sorry, the word volume has 6 letters. How many ways the letter of the word volume be arranged so that first position is occupied by the letter L? Okay? By the letter L. Are you okay? Are you understanding? Do you want me to explain it again or not? Are you okay? You are okay? Okay. Second question. Vowels are together. Vowels are together. Second question, how many ways the letters of the word volume be arranged so that vowels are together? So volume has V, L, M, and then O, U, E. These are the vowels, right? These are the vowels, right? So vowels are together. So vowels together is only one word, only one letter. And how many consonants? 3, right? 3 plus 1. How many letters now? 4, right? So letter 1, letter 2, letter 3, letter 4. Are you understanding? Vowels are together. One of these box will be occupied by the vowels. Yes.
This is together the vowels. So it's not going for you just see the
Good question. It could be any of that way. It could be O, U, E, or O, E, U, or E, O, U, or E, U, O, or U, O, E, or U, E, O. Any of these. But that any of these should go in any other, but remaining three will be like that. Okay. So she asked me question. It should be vowel should be together can happen 6 ways. O, U, E, O, E, U, E, O, U, E, U, O, and then U, O, E, and then U, E, O. Clear, right? How many? 6, right? 6 arrangement, right? So 6 arrangements, she said. So now just consider only one arrangement in here. So how many ways these 3 can be arranged? Yes. These 3 can be arranged in 6 ways, right? These 3 can be arranged in 6 ways, right? So that is 6 and times this one, this vowel would be 6, right? So 36 ways, right? You understand or not? Please ask me question if you do not understand. Okay, let me explain this again to you. Vowels are together, right? So 3 vowels together, I consider only one letter. This is for the only one letter that stands for a vowel. So suppose this is V1. 3 letters together as a vowel, this is 1. And then remaining 3 as a consonant, which are L, M, and V. These V1 is 3 letters, right? What is that? O, U, E, O, E, U, E, O, U, E, U, O, U, O, E, U, E, O. Do you agree with that? These 3 letters would be the vowel, right? Okay. Clear, right? Okay. Now, these vowels would appear in first position, in second position, in third positions, right? Okay. Suppose these 4 letters, this is V1 means one vowel, and this is like L, M, and V. So these 4 can be arranged among 4 permute 4, which is equal to 24, right? You understand? You understand? Now, this is just only one, but how many of these? This is just only one, right? But how many of these? V1 is appearing how many ways? So 24 times 6. You understand? So final result is 24 times 6. Previously what I write is not right. So this is the correct answer. You understand, right? Previously what I write is not right. So this is the correct answer. Do you get it? Do you get it? Anyone did not get it? You can ask me question. Yes.
Is that 6 pre-permutation free or is it just because of this?
So 3 vowels together, right? That would be, it should be together. So this can come first position, second position, third position, fourth position, right? So that means all of this, if we consider there are 24. But here, I just consider only one. But how many of these? There is 6 of this, right? So that is when multiply by the 6. Thank you for asking these things. Otherwise, maybe I will skip it. You got it? You want me to explain it again? You got it? You got it? Okay. So number 3. So first of all, first question I did the letter M or letter what? Letter L appear first position, right? Second, vowels together. Vowels and consonants together. Vowels and consonants together. So in our country, when we learn the English alphabet, from the first grade, we learn English alphabet, okay? We learn 5 vowels, A, E, I, O, U. But I did not know that the letter Y is also considered vowel. So, you know about that? No? Letter Y is also called vowel, right? And do you know without vowel, you cannot form any word? Do you know that? You cannot find one English word that does not have a vowel. You know that, right? I did not know about that. I did not know about that up until my daughter went to school. Really, I'm speaking, I'm admitting. I had a very, very good GRE score in GRE, what is called, the English, verbal part. Very good GRE score I had. When I took the GRE score, dictionary is almost memorized by myself. But I did not know that without vowel. Okay. Now vowels and consonants are together. So if you put their vowels in here and consonant in here, for vowels, you have 3 letters. This is called U, E, and O. And for that one, M, L, V. Understand? So if I draw the figure, so here I want to put consonant, here I want to put vowel. So these 2 letters can be arranged themselves in 2 ways. 2 permute 2, which is equal to 2. It could be vowel, it could be consonant, consonant, vowel. First vowels come, then consonants come, right? 2 ways. But this is the 2 ways, these 2 ways. Vowel, consonant, consonant, vowel. This is the 2 ways. Then consonant can be arranged among themselves 6 ways. Vowels can be arranged among themselves 6 ways. So that means 72. Are you understanding these things? Are you understanding these things? Are you understanding these computations? Vowels and consonant together. So that means all vowels together in first position, or all vowels together in the second position, or all consonants together first position, all consonants together in the second position. So that could be done VC or CV. But V can be arranged, all the vowels can be arranged in 6 ways, all the consonants can be arranged among themselves 6 ways. Right? So in your exam, if I give you a word, ask you like this way, understand, right? First position is occupied by L, and last position is occupied by N. So position 1 occupied by L, position 6 occupied by N. So can anyone of you tell me the answer? (24), right? So this position is occupied by 4. Then one of the 4 letter gone in here. One of the remaining 3 letter, one of the remaining 2 letter, 24. How many questions are solved? Seven together, now do the 5. L always appears before M. I want to give you 5 minutes. Who can solve it? L always appears before M. If you can solve it, in next 5 minutes, I will give you secret credit. Nobody knows. You, me, and God. Nobody can complain. So, yes. Is it also 34? It is what? 34. 24? No. Not 24. Yes. 5,400. No. No.
Ask me, is it in the thousands?
No. I computed it. Now I deleted it. So that is why. Okay, so I already got 1, 2, 3, 4 answers. Okay. Okay. I want to take other answer. I want to take other answer. Let me see. Let me see what other students. These students, that is students. The online student Grace Osibanjo. Grace Osibanjo.
Yeah.
How many ways if I arrange the letters of the word volume, how many ways the arrangement from the arrangement, the letter L always come before N.
I did not get that.
What?
I couldn't hear you. What did you say?
So the letters of the word volume is arranged. How many ways the letter L will come before letter N?
Okay.
What is my word file?
1, 2, 3, 4, 3. How many words? Is this 7? 1, 2.
So the question is, let me see, this recording is still? Okay, it is still recorded. How many ways the letter of the word volume be arranged so that letter L appears before M. Another thing I want to tell you, factorial will be applicable only for the integer number. For a decimal number, factorial does not work. Understand? Factorial 2.5 does not work.
You said it wasn't in the thousands?
So it is not in the thousands. Okay, take a look. CAT, cat, right? CATAC, TCA, and ACT, From there, take any letter. How many times A appear before T? This is the A appear before T, A appear before T, A appear before T. Understand?
Yeah.
So, T letter can be arranged. Are you understanding? Are you understanding? Then volume. You understand now?
I think I could be wrong. I can never be wrong. Hold on.
Now take a look. 6 permute 6, right? Divided by 2, right? Then what? 6 permute 6 equal to what? 720, I guess, right? Divided by 2 equal to 360. Always. Whatever, it is a 4-letter word, 3-letter word, 5-letter word, 6-letter word, always half of it.
So
Go ahead.
never mind.
No, I will mind. Yeah.
I understand what you did now.
You understand now? Whatever you will do, it will always be like that. Another way, in order to convince you, I have to do it another way. Okay? Long way. Long way. When I first did this problem, so it was a homework problem in undergraduate when it was given. I did this way. I take this way. First L and rest of this M. Understand? So 1, 2, 3, 4, 5, 6. So how many ways this is? 5 permute 5 equal to 120, right? L always appear before M, right? Okay, now come. This is the case 1. Case 1, L is in the first position. Now number 2, case 2. L is in the second position, right? Right? If L is in the second position, M must be in here, right? So how many letters remaining to occupy first position? 4. 4 times 1, right? And times how many in here? 4, which is equal to 24. 24, right? So 24. So 24 equal to what? 96, right? Are you getting or not? Now I am going placeholder by placeholder. Each placeholder should have a letter L. Before that, there should not be M. Are you understanding? When I was an undergraduate student 20 years ago, this homework problem, I solve it like that way. And then I give it, then professor said that, well, you go by placeholder by placeholder. You put L in the first, and then you put here. Then I said that, well, L is in the second position. M must not be in here. What will be in here? Any of the remaining 4, right? Then this is 1, then that is 24. Then I go to the third case. First 2, this is the L, this is the 3, right? So that could be, this is equal to 6, right? This is equal to 6. 1, 2, 3. This is equal to 6. This is equal to 1. This is equal to 3, 4. M should be in here, right? M is gone in here. So L and M gone. How many remaining? 4. 4 and then 3, right? Are you understanding? M is in here. So why is in here? 4 is in here. Because M must be in here. So I cannot bring M in here. So M is in here. So now I have what? 24. 24, right? Now come to the scenario of 1, 2, 3, 4, 5, 6. This is 2, this is 1. This is equal to 1, which is equal to L. This is 4, this is 3, this is 2. So here equal to 48. No, so what is?
Oh, the third one is 72.
72, right? And then fifth one is this. 1, 2, 3, 4, 5, 6. This is L, this is M. This is 4, 3, 2, 1, 1, 1, 24. Now we have what? 24 plus 48 plus 72 plus 96 plus 120, right? Sum them up. This would be equal to 360, I guess. Are you getting? Are you understanding? So these are computational thing, which is the fundamental thing. Okay. So now after this computational thing, now I want to do some permutation and computations together with basic principles of counting. Permutation and combination. So let me do like this way. So now I want to do combination with basic principles of counting. After this, then I will stop. A box has 20 marbles. A box has 20 marbles. Marbles. 8 of them are red. 5 of them are white. 4 of them are blue. A box has 20 marbles. 8 of them are red. 5 of them are white. 4 of them are blue. And 3 are suppose black. Okay. So 20 marbles. 8 are red. And then 8 are red. 5 are white. 13. Blue. 3 are black. Okay. 8 are red. 5 are white. So now 4 marbles are randomly picked. Four marbles are randomly picked. How many ways 4 marble can be picked? Can be picked. This is the first question, okay? How many ways? How many ways 4 marble can be picked? This is 24, choose 4, okay?
Say, marbles that color.
No. And you know how to find this by using calculator or Python, right? Didn't I show you how to compute these things in the Python by using factorial? Yes. You remember like the computational formula e to the power x divided by factorial 1, factorial 2. What?
Answer.
Yeah. Let me see the regular fact. Fact does not work. You have to take a look at the basic computation part 2. It should have something where I mentioned factorial. It's maybe in the homework problem I gave you. Python code to find factorial. np.fact, I guess. Let me see. Come. Oh, this is just the factorial. Let me see, just the factorial. Factorial. See. Factorial is not obtained. Factorial. There is no built-in things. You should have something built in. I don't want to write any function. Math.factorial. Let me see. Math.factorial. Math.factorial 4. Math is not defined. Import math. Here you go. Math.factorial, okay? What I was teaching you. So 24 choose 4. So the answer is how many ways 4 marbles can be picked? So this is the answer, okay? So that should be like factorial 20, factorial 4, and factorial 16. So this is the answer, okay? So now after this, let me do number 2. So 4 marbles are randomly picked. Then 2 are red. 1 is black. And 1 is white. 4 marbles has been picked. How many ways 4 marble can be picked so that 2 are red, 1 is black, and 1 is white? Are you understanding? 4 marbles, I took the 4 marbles. How many ways you can get 4 marbles so that 2 are red, 1 is black, and 1 is white, right? So how many red there? 8 red, right? So 8 red, 2 red can come how many ways? Red 1, red 2, red 1, red 3, red 1, red 4, red 1, red 5. Are you understanding? This way 2 red is coming. Red 1, red 6, red 1, red 7, red 1, red 8. Then red 2, red 3, red 2, red 4, red 2, red 5, red 2, red 6, red 2, red 7, red 2, red 8, then red 3, red 4, red 3, red 5, red 3, red 6, red 3, red 7, red 3, red 8, red 4, red 5, red 4, red 6, red 4, red 7, red 4, red 8, red 5, red 6. In this way, all the reds you will find, right? Right? Then red 5, red 7, red 5, red 8, red 6, red 7, red 6, red 8, red 7, red 8. Okay? Which is equal to 8, choose 2, 8 to factorial 8, factorial 2, factorial 6, which is equal to 8 times 7 times 2, 4. This is 28 way. So the 28 way you can find this. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17. 3 and 7, 17. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. This is the 28 ways, right? Are you understanding? So 2 ways and 1 black. How many black is there? 1, 2, and 3. Either you can get black 1 or black 2, black 3, right? And how many white? 5 white. You can get 1, 2, 3, 4, 5. So now you can ask me question, how can I find this? So this is what you can do by basic principles of counting. 28 times 3 times 5. How? How? Take a look at that. Take a look at the board. This is one option. This is one option. This is one option, right? That is one option. This is one option. This is one option. This is one option. This is one option, right? Are you getting it? That is the way you can get way. So, and then all white. All white. All white, how can you get that? So there are 5 white, right? So then 5, choose 4, right? That is the way you can get all white, which is equal to just 5 ways. Five ways you can get all white balls. Huh? Why choose 4? Because this is combinations problem. This is, take a look at the white 1, white 2, white 3, white 4. Okay? White 1, white 2, white 3, white 5. Okay? Then white 2, white 3, white 4, then white 5. Okay? Then white 1, white 3, white 4, white 5. This is gone 1. Then all 5. So because the all white coming from all 4 white ball is coming from all 5 white ball, right? There are 5 white ball, then all 4 white must come from white ball, right? So that is why 5 choose 4. So 5 choose 4, factorial 5, factorial 4, and factorial 1, which is equal to 5. And how many way? This is one way. First white, second white, third white, fourth white. or first white, second white, third white, fifth white. And then you can do here first white, third white, fourth white, fifth white. So this is the combination. And finally, you can get one of them could not be in there, maybe white 1, white 3, white 3, white 4, white 5, white 2, white 3, white 4, white 5. Then white, what is the other one? White 1, white 2, white 3, white 4, white 1, white 2, white 3, white 5, white 2, white 3, white 4, white 5, white 1, white 3, white 4, white 5. And then white 2. Can you find another one? 4, right? Okay, let me write it clearly in here. So 5, white 1, white 2, white 3, white 4, white 1, white 2, white 3, white 5. So let me do white 1, white 3, white 4, white 5. Now white 2, white 3, white 4, white 5. How can I find another one?
White 1 and then that.
No, very last I cannot put white 1 because there is ordering doesn't matter.
Sorry.
White 1, white 4, white 5. That is not possible. White 2, white 3, white 4, white 5. All are 5 choose 4. 5 choose 4 equal to this. White 1, white 2, white 4, white 5. White 2, white 3. I have to find another one. Can any one of you find this? 5 choose 4. God bless you. Could you think about this? White 1, white 2, white 3, white 4. White 1, white 2, white 3.
1, 1, 2, 4, 5.
1, 2, 4. Oh, thank you.
Yeah.
This is not a head. Oh my goodness. You know, I was surprised why I cannot find it. You know what happened? A famous statistician was visiting our country. Who is the founder of statistics? His name is R.A. Fisher. I'm talking about 1952, something like that. And he's the founder of statistics, R.A. Fisher. His name is Sir R.A. Fisher. And the person who founded the statistics department in our country, his name is Mohtar Hossain. So people are gathering there, and very simple thing was not coming to the head of the Mohtar Hossain. And in front of the audiences, he is asking to the R.A. Fisher, I actually do not know how this coming to an existence, and I cannot think about this. So the R.A. Fisher says, oh, this is very easy. He just go and prove this thing in the board. And then he said, oh, sorry, I'm sorry, I am asking you. Then R.A. Fisher said, oh, don't, never mind. Sometimes it's happened in your life. You do not understand something. Then what he did, as his PhD